All right, so today we're going to be going over dependent and independent variables. All right, so let's kind of review some things that we may know before we jump into this lesson. If I say that you're doing independent work, what does that mean? Put that in the chat. Franco.
By yourself.
Very good. So when we're talking about independent variables, they are variables that stand by themselves, okay? Dependent is the opposite of that. So what does dependent mean? Caleb?
Together.
Okay, so your dependent variable depends on something. I want you to think of this way. Each one of y'all are dependents. You depend on your guardians, whoever you live with, for food, for a roof over your head, for your clothes. Okay, you depend on someone to pay for those things. Me, your teacher, I am an independent because I have a job that pays for all my stuff. I have a job that pays for my clothes, that pays for my food, pays for my house. Okay, and I work my own job. Y'all are not old enough to work jobs yet and pay for everything. So you are a dependent and I am an independent. So that's a good way to think about this as we're going through this lesson. Okay, now on the next page, let me get to it. We're going to be going over some notes on independent and dependent. So in this first side, when you open up your copy, yours are blank. So you're going to have to end up typing in yours because I made a copy for each of you so that you could follow along with the lesson. Okay, so independent variables cause change in the blank variable. What does the independent cause a change in? Chat it up. I filled it in for you. The independent variable causes change in what, guys? Franco, what does it cause change in?
The dependent variable.
The dependent. Very good. Now, if we're looking at this, we see we have our independent here, which is going to affect. Okay, that keyword affect is going to stick with us a couple times. Okay, it affects your dependent variable. Okay, so changes are caused by the independent variable. Now, if we're talking about this, remember your independent can stand by itself. It's going to be what it is no matter what. Your dependent depends on your independent variable. So if we're looking at this little word problem right here, okay, a lot of times when we're talking about independent and dependent variables, you're going to get a real world situation and you're going to have to be able to determine what the independent variable is and what the dependent variable is. So if we are looking at this, it says Jackie tested how the height of the ramp affects the distance of the toy car. Now there is a key word in there, okay? Keyword, affected. Circle that or make note of that. Some keywords that you need to keep in mind. Affects, affected, and depends. Now, when we are talking about relationships between independent and dependent variables, you'll see a bunch of these keywords. And in this one, we have the word affected. Okay, so it says, Jackie tested how the height of the ramp affects the toy car, the distance of the toy car. So if we're thinking about this, which one's going to stay the same no matter what? The height of the ramp or the distance the toy car goes? Jace.
The height of the ramp.
Very good. So the height of the ramp is going to be your independent variable because that's going to stay the same. Now, depending on the height of the ramp, our dependent variable is going to be what? Maria? Your distance traveled. Very good. Okay, so here we had to determine which was which. Now, when we're talking about independent and dependent variables, we have graphs. We're going to have to know which one falls on the x-axis, which one falls on the y-axis, and creating tables and all of that good stuff. Okay, so if we look a little bit further down, our independent variable always falls on which axis? Caleb? Caleb, which axis does it fall on? Might be something wrong with your mic. Camden, help him out.
X-axis.
Very good. Our independent always falls on the x-axis. So when we're labeling a graph, remember our x-axis is horizontal. Okay, so we have our x-axis here, and that independent variable, which is the height of the ramp, is going to go in that blank. Okay, so we have the ramp there. Okay, and on this side was where our dependent variable is, which is which axis. Our dependent is on what axis, guys? Maria?
Y-axis.
Your y-axis, and that one is vertical. So we know that we would have our distance traveled as our y. Okay, so anytime that you see independent variable, I want you to say, put an X there so you just automatically know. Anytime you see the word dependent, put a Y there so that you automatically know. Okay, we're going to be going in to some different things. Now, there's an example I want you to think of. And when we're talking about independent and dependent variables, when we talk about time, think about this. Time. Whether we're watching TV, whether we're sitting here on Zoom in class, whether we're outside running around, or we're eating lunch, time is going to pass anyway, isn't it? Yes or no? Ezekiel, is it going to pass anyway?
Yes.
It is. So since time is going to pass anyway, no matter what is happening, would time be an independent or dependent variable? Camden.
Independent.
Very good. So anytime you see something dealing with time, it's going to be an independent variable. So write that note down. Okay, so, excuse me, that's dealing with time. Now, there's another thing that we usually deal with when we're talking about independent and dependent variables, and that is money. Okay, so if we're talking about money, think about this. I have a job and I make a wage. I make something for every hour that I work, right? So depending on how much time I work is how much money I'm going to get. Okay, so if that's the case, money is always going to be a what kind of variable? Caleb, see if your mic's working now.
Dependent.
Very good, yes. So money is going to be dependent. Most of the time, your situations are going to either have time or money, or they'll have both. But if they only have one of the two, you can use process of elimination to cancel one out to figure out what the other one is. Okay, so make sure you have those notes down, and then we're moving on to the next page. I'm going to give you a moment to write those notes down. If you are done writing those notes, I want you to move on to the next page. And at the top, there are some examples, some independent and dependent variables. I want you to try to match those. Use an arrow to match those. All right, so if we are looking at this, and we're talking about our independent and dependent variables, just for the sake of helping us identifying them, we're going to put letters and numbers on top of them so we can kind of match them easily while we're talking about them. So if we're talking about the amount of sunlight, if that is my independent variable, what would be dependent on the amount of sunlight? Put that in the chat. Good, Maria? Good, Jace? Good, Camden? Bryn, tell me.
Height of plant.
Very good. It is the height of the plant. So we would draw a line right there. Now, time spent studying. What would be dependent on the time spent studying? Jace, tell me.
The test grade.
Very good. Yes. Your test grade. And guys, y'all are drawing lines on yours because remember, this is going to end up being your own assignment. Up here where it says line, that's how you draw a line. All right. So if we're looking at the next one, minutes spent exercising. Okay. What depends on the minutes exercise? Maria.
Calories burned.
Very good. Our calories burned. Okay. And that leaves our number of tickets sold. What is depending on the number of tickets sold? Yes, Andrew. Camden, tell me.
Amount of profit.
Very good. The amount of profit. Okay. So are we kind of catching on to our independent, how an independent variable can stand by itself, but it will need a dependent variable needs an independent in order for us to know how they're being affected by one another. Okay. So let's look down below where Carly earns $9.50 for every hour she works. Okay. So the first thing's asking us is, let's find our independent variable. Now, what axis did we say our independent variable was on? Franco?
The x-axis.
Very good. So we know our independent variable is our x-axis. So I'm just going to go ahead and write that there just so that I know. And then our dependent variable, which is our money earned, is going to be which axis? Camden.
Y-axis.
Very good. Okay. So now even looking at this, if we think about our notes from before, we said money is always going to be a dependent variable. And whenever it's talking about money earned, that's money. Okay. And we said that that was a dependent variable. You see how it's all matching up on us now? All right. So the next part, it says, what is the relationship between the independent and the dependent variable? So we have to write a sentence. Okay. Remember our keywords. When we're writing sentences, we have to use keywords like depends, affect, now, depending on which of these words that you use is which one comes first. So if we use the word depends, we have to put our dependent variable first and then the word depends followed by our independent variable. If we use one of the words affects or affects, we would put our independent variable, one of those keywords, and then our dependent variable. So go ahead and give that a shot. In the chat, type me what a sentence of that relationship between the independent and dependent variable. Go. All right. So if we're looking at this, Ezekiel, give me your sentence.
So I said the amount of money Carly gets depends on the amount of hours she works.
Very good. Yes. So if we're using the word depends, we have to put the dependent variable first, which we said was the money earned. So the money earned depends on the hours worked. And guys, when it's talking about you using or determining the relationship between the two or writing a sentence to determine the relationship, you have to use the labels they give you on the graph. So we're not using the words independent variable and dependent variable. We're using what those words stand for. Okay, we're not just using X and Y. We have to use the group of words, the labels, as for what they stand for. Okay, all right. Now, if we're going over here and looking at this table, okay, when we deal with independent and dependent variables, we have tables as well. Now, think back to when we did ratios. When we did ratios, we worked with tables. Guys, this is the same exact thing. Okay, remember what we do to one, we do to the other. Okay, we work our way down. In ratios, we're filling in blanks. Okay, here they give us all of our blanks, but we're going to have to figure out equations that go along with the table. So if I'm looking at this, we have our independent variable, which is our X, our hours worked, right here. And what did I do to the one to get to $9.50? What operation did I use and what did I do to it? Chat it up. Maria, tell me. We're multiplying by 950. Okay, and remember what I do to one, I have to do to the other. So if I wanted to check myself all the way down, I would take the 2 and multiply by 950. All right, so down here, and it goes the same way with the 3. And if I multiply that out in my calculator, I would get the answers of my y's over here. Okay, so if I'm looking at my equation, which is y equals 9 and 5/10 times x, guys, if we want to switch it around because we're used to seeing it the other way, we can. So if it's the same thing as saying 9 and 5/10 x equals y. So whichever way is easier for you to see it, do it that way. Okay, now if I'm looking here, remember we can use, what is it called when I take a number and put it in place of a variable? Caleb? Ezekiel?
It is called substitution.
Very good. So if we wanted to check ourselves in this equation, remember we were multiplying this right here, these numbers right here, which are our x values, by $9.50. Well, we're doing the same thing right here. We've got the $9.50 and we're multiplying it by our x values. So I could plug that in and I could have $9.50, plug in the 1 if I wanted to start at the top. For my x, use substitution and equals, and they said their y equals $9.50. We could go ahead and work this all the way through to see if it matches up. What is 9 and 5/10 times 1? Graceland?
9 and 5/10.
Very good. Anything times 1 is itself, so it gives you 9 and 5/10. And 9 and 5/10 is the same thing as $9.50 because we could put a 0 at the end of that and it doesn't change the value. So it would check out. Now I know these equations can be a little difficult at first, but we will have quite a few, we'll have a lot of practice with these equations. Okay, so we're going to move on to the next page to get a little bit more practice on this. All right, so here we have these examples. Okay, we have the numbers, we have example 1 and example 2. What I want you to do is I want you to take a moment and figure out the independent variable and the dependent variable of each of these examples, and then put it in the chat for me when you're done. Go ahead and do that now. All right, so if we're looking at example 1, remember the notes that we talked about. Time is always going to be what? What is time always going to be? Chat it up. Maria? Very good. It's independent, if I can spell correctly. Okay, and we said money is always going to be what, guys? Camden?
Dependent.
Very good. Okay, so keeping that in mind, we can take that and we can kind of narrow things down over here. So we have number of weeks and money saved. Weeks is a form of what, guys? AJ? Very good. It is a form of time. Okay, so since it's a form of time, we automatically know that it is an independent variable. Come on. Okay, so if we know the number of weeks is our independent variable, our dependent variable is going to be the what? Ezekiel?
Money saved.
Very good. Okay, so now that we have that, let's go on into example 2 and let's talk about our independent and dependent variable there. Now in this one, they says student government is selling carnations for the Valentine's Day for $2 each. Okay, so we have number of carnations and amount of money sold. Now remember, we have some key words in here that we've talked about. Remember, we've talked about time and we've talked about money. Which one's in there? Do we have time or money in there? Wes? Wes, which one do we have in there?
Money.
Very good. We have the money, and money is always dependent. So we can go ahead and go down to our dependent variable and we can put in the amount received. Now, it doesn't technically say money, but we know that amounts received has to deal with money. So you've got to think of it that way. So since we've canceled one out by process of elimination, which one's going to be our independent variable? Ezekiel?
Number of carnations.
Very good. Our number of carnations. Okay, so like I said before, if you remember these two things about time and money and which one's which, you can use processes of elimination for the other ones. Okay, so we're going to move on to the next page there and get a little bit more practice with these before you do a little bit on your own. Okay, so now we are going to be talking about how we're looking at a graph. Remember, our independent variables, what axis is our independent variable? Which one is our Rajan, which one is our independent variable, baby?
X-axis is the independent variable.
Very good. Okay, now if we're talking about our dependent variable, which axis is that, guys? Put that in the chat. Stephen?
Y-axis.
Very good. Okay, so keeping this in mind, remember, you are using the labels that are attached to these X and Y axes to figure out which one's your independent variable and which one's your dependent variable. And then you're describing the relationship between the independent and dependent variable. I want you to take a minute and do this one on your own and then put your answers in the chat. Go. Okay, so if we're looking at this, remember our independent variable is our x-axis. So my independent variable is going to be what? Steven, tell me what my independent variable is going to be.
The number of people.
Very good. That's on my x-axis. So we know the number of people are going to be my independent. So that leaves what as my dependent? Put that in the chat, guys. Camden, what does that leave my dependent variable to be?
Cost of admission.
Very good. And cost has to deal with money. And what we said is money is always going to be dependent there. Okay. And now if we are talking about the relationship, depending on the key word you use, depends on what's going to go first. Okay. So if I am looking at that, Andrew, can you please give me your sentence?
The cost of admission depends on how many people there are.
Very good. Right. So we should be kind of getting in the groove of hang things. So make sure that you understand which ones. Remember, your x-axis is your horizontal, your y-axis is vertical. Okay. Now on the next one, I want you to take a minute and I want you to try this last one before we kind of review of what we went over. All right. So go ahead, take a minute, and I want you to figure out what the independent and dependent variables are, and then how much each earned per lawn. Go. All right, so looking at this independent variable, remember our independent variable is our x-axis. So what is the label on our x-axis? Put that in the chat. Maria, what's our independent variable?
Number of lawns.
Very good. It's our number of lawns mowed. Okay, now if we're talking about our dependent variable is going to be what, Ezekiel?
The earnings.
Very good. And remember, we talked about money being dependent, and earnings has to deal with money. Okay, and now we've got to figure out how much is earned per lawn. Now, if we're looking at this graph and we have our X value, let's look at this first coordinate, this first ordered pair right here. Our X stands for which number? No, look, if I'm looking at this first dot on this graph, what is it going to represent on my x-axis? Which number? Megan?
2.
Very good. And if we're looking at that same dot, but we want to see our y-axis, our y equals what? Put that in the chat. Steven?
30.
Try that again. That's not a 30. It's a what?
Two.
Maybe I just squared it in. That's not a 30.
Okay.
It's a 50. Okay? Your eyes might.
You put a 3 on my paper. That's why I thought it was a 30.
It's a 5. So looking at this, remember we have our dependent. Hold on. Over our independent. So we know that that fraction bar means division. So our dependent was 50. Our independent is 2. So 50 divided by 2 equals 25. And that's how we got $25 per lawn. And if we want to do that with the other one, it would be the same way. Because if I use this other dot, I would have a y-axis of 100. And I would divide it by the x-axis of 4. And we get 100 divided by 4, which still equals 25. Okay. All right. Let's kind of review what we went over today. Remember, when we were talking about tables, you have your X and your Y. Your X is your top. It's your first one. Your Y is your bottom, and it's your second one. When you're talking about graphing them, you have your ordered pairs, which is X and Y. Remember, in the ordered pair, the X comes first, and then the Y. And your X is still your independent. Your Y is your dependent. Okay? When we're talking about equations, our y is still our dependent variable, our x is still our independent variable, but then we're going to throw in a constant and a coefficient every once in a while. Okay? And then writing the relationship, remember, if we use our dependent variable first, we have to use the verb depends. And if we use our independent variable first, we have to use the word affects. Okay? So those are just some points that we hit throughout this lesson. Okay, guys? The announcements are about to come on. So if you are good, I will see you tomorrow.
Good afternoon, everyone.